All right, we're going to pick up where we left off in terms of using lines in a real life situation to help us model between converting different temperature scales. So Celsius, Fahrenheit, Kelvin is also a temperature scale, but we'll just focus on Celsius and Fahrenheit right now. There are a couple pairs of Celsius and Fahrenheit values that it's kind of common knowledge. It's something that you should have as in your body of knowledge, what water freezes at and what water boils at in each of these scales. So let's go with freezing. The pairs of values for water freezing would be 0 degrees if we're on the Celsius scale and 32 degrees if we're on the Fahrenheit scale. So just for your own personal knowledge, if you don't know that already, that's something that kind of an educated, intelligent human would know that as an adult. So, and then boiling, the boiling temperature for water. Water boils on the Celsius scale at 100 degrees and on the Fahrenheit scale at 212 degrees Fahrenheit. And so if we want to find a linear equation for these, we would first need to determine the slope. And so we'll use the slope and the increment values between the y terms. So that would be 212 minus 32. And the increment values for the x terms, which would be 100 minus 0. So we're looking at 180 over 100, which reduces to 18 over 10, and reduces one more time to 9 over 5. So we have our slope equation. And then I think I'll use the pair 0, 32 to write the line. So y minus 32 as the y value equals 9/5, x minus 0. And I don't need to distribute, that's as far as I can take it. This is the linear equation that will convert any Fahrenheit to Celsius or Celsius to Fahrenheit. So we're going to use that equation to convert normal body temperature. So y minus 32 equals 9/5 of x minus 0. And remember, x is the Celsius and y is the Fahrenheit. So if we want to convert normal body temperature, so we're scanning everybody's temperatures nowadays to make sure they're not at risk for COVID. So normal body temp is 98.6. And so you're determined to have a fever if your temperature is over 100.3. And so let's see what 98.6 turns out to be on the Celsius scale. So 98.6 is a y value for Fahrenheit. So we'll put 98.6 in for our y value. Subtract 32, and we'll have 9/5 of x times 0. And now we want to solve this. When we subtract, we get 66.6 equals, and then we're just left with 9/5 of x. Now we want to solve for x by multiplying by the reciprocal. So we'll multiply both sides by 5 over 9. And so x is going to be the product of 5/9 times 66.6. And so that turns out to be 37 degrees. So a normal human body temperature on the Celsius scale would be 37 degrees. And incidentally, it's when you get to 38 degrees on the Celsius scale, which corresponds to 100.3 on the Fahrenheit scale, that's when we determine that your body is having a fever. Okay, now we're going to wrap this up by talking about linear equations that are solved simultaneously. And there are a couple different methods we can use to do that. We're going to do, we'll review. There are many ways to do that. You can do that by graphing, you can do it by substitution, you can use a matrix to solve it, but the most common we're going to use is the process of elimination. So we're going to review that together. So here's a unique pair. A system usually is joined by a bracket there, and we want to solve these equations simultaneously, find the single solution which satisfies both of them, and we'll use elimination to do that. The elimination method is where you look at the x values, or you look at the y values, and you want to make them eliminate each other, cancel each other out. And so right now, because the y's have opposite signs, I'm going to eliminate the y's using multiplication. So I'm going to multiply this entire top equation by the constant value 3, and then I'll multiply the entire second equation by the constant value 5. And that's going to give me a whole new equivalent system, but that can be eliminated. So when I multiply by 3, I'll have 9x minus 15y equals 39 times 3, so 117. And in the second equation, I'll have 10x plus 15y equals 35. And now this is set up beautifully to do elimination because I have a positive and a negative 15, and so the y values eliminate each other. And so when we combine these equations, we end up with 19x, that's 9 plus 10, equals 117 plus 35, so we're looking at 152. And then when you divide both sides by 19, you find that the solution for x is 8. Now we want to work backwards and find what the solution would be for y. And so we'll take the value of 8, and you can plug it back into either of the equations. I'm going to use the bottom equation. So 2 times the value of 8 for x plus 3y equals 7. So that's 16 plus 3y equals 7. And when I subtract 16 from both sides, I'll get 3y equals negative 9. And so y is, by division, negative 3. So the solution is written as an ordered pair, 8 and negative 3. Now that represents a solution is written as a unique pair because it also represents what the equation looks like when you graph it. Okay, when you convert these equations into calculator-ready form, in other words, you subtract 3x from both sides, oops, and then you divide by 5, and then you get this equation here, 3/5 x minus 39 over 5. And you do the same thing for the second equation to get y by itself, and then you graph it. You find that the intersection is 8 and negative 3. And so you can confirm this by graphing as well. So those are the two most common methods that we'll use. We don't use matrices a ton. You can use it if you enjoy matrices, but we mostly use elimination and graphing, and occasionally we'll use substitution as well. So here's another system for us to solve simultaneously. I don't have any opposites right now, and so I'm going to solve by multiplying by a negative number. So I'm going to take the top equation, I'm going to multiply it by negative 2. So that will give me negative 4x minus 10y equals negative 40. And then my second equation remains unchanged, positive 4x plus 10y equals 10. And now when I solve that, I notice that the x's eliminate and the y's also eliminate, which means I'm left with nothing on this side and then negative 30. Now I run into a problem because both of the variables eliminated and 0 is not equal to negative 30. That means this is an inconsistent system. There is no pair that will solve these both at the same time. And so what would that look like if I used the graphical method? So the quickest way to graph these is to do the intercept method. And so remember, if I replace x with 0, then y would be 4. And then if I replace y with 0, x would be 10. So I'm going to be connecting y to 4 and x to 10. So we'll estimate that to look like about here. Try and draw that a little straighter. Okay. And then the second equation, if we use the 0 method there, we'll get y equals 1. And then if we use 0 here, we'll get y equals 2.5. And so if I connect 1 to 2.5, okay, these lines don't intersect at all. These are parallel. They have the same slope, and so we call this an inconsistent system. It has no solution at all. And then let's go back and revisit to finish up an equation that's the same in both Celsius and Fahrenheit. So we have our equation that we came up with, y minus 32 equals 9/5 of x minus 0. So we know that's the conversion equation, but we want Celsius and Fahrenheit to be equal. And remember that Celsius is the x and Fahrenheit is the y, and so we want x to be equal to y. So this is not a good system to solve with elimination, but it's a good one to solve with substitution. And so I am going to replace x with y in this equation. So that will give me y minus 32 equals 9/5, and I'll replace that x with y. This is a direct substitution. So we have y equals, or minus 32 equals 9/5 y. Now I'm going to multiply everything by 5 because I don't like working with the fraction. And so I multiply this number by 5, y by 5, 32 by 5. I'm going to multiply 9/5 by 5. It's going to give me a more simple equation to work with. So I'll have 5y minus 32 times 5, so 160, equals 9y. Now I'm going to subtract 5y from both sides. So I'll have negative 160 equals 4y. And then I'll divide both sides by 4, and I'll get negative 40. That means that negative 40 is the same in Celsius or in Fahrenheit. That they mean that's the only place where they mean the exact same thing. So if you say negative 40, it wouldn't matter. It's cold, 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 no matter what. It's the same in Celsius as it is in Fahrenheit. So that's the substitution method. All right, so you have seen the elimination method, and then what the graphing method would mean, and what it would mean if you came up with parallel lines that didn't intersect, and then the substitution method as well. So that finishes up 0.1, and you should be able to finish 0.1b assignment and have that turned in, and we'll tackle 0.2 next week.